How's it going, guys? Today we're going to be going over a problem called first bad version. First bad version is a leak code question that's commonly asked by Facebook and Google. The problem description says you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest product version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after the bad version are also bad. Suppose you have n versions, 1, 2 to n, and you want to find out the first bad one, which causes all the following ones to be bad. You're given an API bool is bad version, which will return whether the version is bad. Implement a function to find the first bad version. You should minimize the number of API calls. So here's an example where n is 5 and version 4 is the bad version. So we can call is bad version 3, that returns false. Is bad version 5 returns true. Is bad version 4 returns true. Then 4 is the first bad version, because we know 3 returned false, meaning it's not a bad version. 5 returned true, meaning it is a bad version. So between 3 and 5, we have to check 4, and 4 is also a bad version. So therefore, we know that 4 is the first bad version. So when we think about this problem, right, a brute force, or I guess like the naive solution, you would say, is O of n. So n being however many versions we're given. So if we just walk through the array and plug into this API call, the ith version or whatever version we're currently on while we're iterating through it, we can very quickly determine what is the first bad version. But in the worst case, we have to go through all n versions to determine what is the first bad version. So a better solution than that is actually binary search. And the reason for this is because if you think about it, this is kind of like let's say we have an array and we can represent whether or not a version is good or bad with zeros and ones. So 0 means that it's, let's say, I guess good, and then 1 means it's bad. So 0, 0, 0, 0, 0, 1, and then all these will be bad after, right? 1, 1, 1, 1, 1, so on and so forth. So we really want to find this first one. So if we think about it like this array is actually sorted, and because it's sorted, we can use binary search. So a bit better of a way to do it, so it's not O of n, but instead the runtime will be log n, is to use binary search. So in binary search, we want 2 pointers. We'll make a left pointer that is set to the first version, and we'll make a right pointer that's set to the nth or the last version. Now we'll iterate while left is less than right. Now we need to calculate a middle point. So we'll say int mid is equal to left plus right minus left. And actually, this is to help prevent overflow at very large values in arrays. So that's a kind of nifty trick. It's something good to know for very large inputs. And to get the midpoint, we're going to divide that by 2. Now we just need to check if, and we'll pass this to the helper function, is bad version of mid. So if it's not a bad version, we want to set left to mid plus 1, so that we can actually traverse to the right subarray. Otherwise, we want to go the opposite way. So we'll set right to mid, and hopefully when this loop terminates, all we'll have to do is return left, because that should be pointing at the first bad version. And so again, guys, this is log n, because at first we start out left and right pointing at the ends of the array. So left is pointing to the beginning, right is pointing to the end. And at every single iteration of this loop, we're picking a midpoint, checking if this is the bad version, and depending on whether or not it is a bad version, we're either going to discard the left half of the array by setting left to mid plus 1, or the right half of the array by setting right to mid. And that will effectively discard half the array every time, and therefore the runtime is log n. So let's check out this solution, see if it works. It does, awesome. Let's check out the details. And leak code tells us we passed 22 out of 22 test cases, and we're in the 99.76 percentile. So guys, this is how to figure out the first bad version in Java. Again, it's a log n solution. This is using binary search. I hope this was helpful. If it was, please do subscribe for all my videos to come. I try and put out a video every single day so you guys see a new video, new interview question. If this was helpful, let me know. Leave a like. And yeah, good luck on your interviews, and I'll see you guys next time.